Okay, in our first two examples, we were given some sort of polygon and we were asked to find what is the angle, the sum of the angles on the inside. So starting with a shape, moving towards the number of the sum of the angles. Now in math, we generally want to be able to move forwards and backwards through any process we do. So if we know how to add, we should also know how to subtract. If we know how to multiply, we should also know how to divide. And if we know how to figure out the sum of the interior angles given some shape, we should be able to find a shape given the sum of the angles. Okay, so in this one, that's what we're going to do. We're going to identify what polygon we have given the interior angle measurement. So the measure of an interior angle of a regular polygon is 144 degrees. Find the number of sides in that polygon. Okay, first thing to point out, they're not saying the sum of the interior angles is 144. They're just saying that one of them is 144. Okay, that'll slightly complicate what we're going to do, but not too much. So if you recall, what we had for our pattern, our little formula that we made based off taking some vertex, drawing out the diagonals, we said that the sum of the angles was going to equal the number of sides we had. So in this case, 6 minus 2. Okay, that 6 minus 2 tells me how many triangles I have when I cut it up. And each of those triangles is 180 degrees. Okay, well, that sum is going to be some amount of angle. So in this case, when we have a triangle when we have a hexagon like this one, I believe what we found was each of these are 120 degrees. Each of the 6 interior angles are 120 degrees. So we'd get 120 degrees times 6. This sum number would be like 720. Now, the thing that's important that I want to point out is that that 720, that sum, could have also been represented like this, as the individual angle times the number of angles. Well, in a six-sided shape, right, if we have 6 sides, we also have 6 angles. So whatever this n is that we're going to use over here on the right side of this formula, we could also put it on the left side. We could say, I'm going to write interior. I'm just going to do int for interior and then the angle symbol. Okay, my interior angle multiplied by the number of angles there's going to be, right? Because if my interior angle is 120, if like one of them is 120, I have to multiply it by 6 to get the sum, right? And this was going to be our sum formula. So this is just a slightly more detailed way to write it. We can write that the sum of the interior angles equals n minus 2 times 180, or we can write that an individual interior angle times the number of angles equals the number of sides minus 2 times 180. Just adding a little bit of nuance there. Now, in this problem, I see that they give us an interior angle of 144 degrees. So we're going to write out 144 times n equals n minus 2 times 180. Okay, so if I distribute on the right side, I will get 180n minus 360. On the left side, I'll still have my 144n. I'm going to subtract 144n from both sides, giving me 36n left over. And then I'm going to add 360 to both sides. I can now divide by 36 on both sides. And doing so will tell me what my n value is. N meaning the number of sides in my shape. So I have a 10-sided shape, which means I'm talking about a decagon, right? If we look at our names of shapes, triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, we are at a decagon, a 10-sided shape. If we were talking about something where we don't know how many sides it has, and we're just going to put in a placeholder, we would call that an n-gon with n number of sides. Okay, but in this problem, 144 degrees corresponds to a 10-sided decagon.